So in this video, I'm going to go over some of the numerical problems that were posed on the worksheet that you were given, and you see them here on the smartboard in front of you. A player is kicking a football from ground level, and it has a velocity of magnitude 27 degrees, 27.0 meters per second at an angle of 30 degrees above the horizontal, and it's going to want the standard hang time, how far the ball travels, and what's its maximum height. So in general, you'd have the level ground, kicking the football through the air. It's kicked at a velocity of 27 meters per second. I'll drop significant digits until the end of the question. Angle of 30 degrees. Question wants to know the hang time, which means time to reach this spot. It's going to then want to know the distance it travels, the range, x distance. And it's also going to want to know the maximum height, which is the height at this instant at the apex of its trajectory. So for the three things that are there. So the first thing you do when we have one of these questions is you need to resolve this speed into its x and y components. You need to convert this into a Vx and the initial Vy and work each one of those out. So to get the Vx, as you'd see from some trigonometry, it is going to be adjacent to the 27 degrees. So you will use speed times the cosine of theta. So that will be 27 cos 30 degrees. And the Vy, I, is going to be 27, the same formula, meters per second, but times the sine of 30 degrees. And so I'll work each one of those out individually. So we have 27 cos 30 gives 23.38. And the sine 30 should be no surprise if you know your special triangles. 27 sine 30 should be 13.5 because sine 30 is 1/2. So 13.50 meters per second. That's upwards, that's in the positive direction. So now I'm going to get to the points of the question if you want to know. So now we're ready to jump in because we know the components of the speed. So to find the time when it's at this height, you have to input what that height is. And at that point, it's on the ground. So the height would be 0. You know gravity. We are going to use negative 9.81 meters per second squared as the acceleration due to gravity. And we're going to solve for time at this point. The formula that you'll use is VIYT plus 1/2 GT squared. You'll input a height of 0. You have a VIY that is 13.5 meters per second times time. And then you are going to put in 1/2 negative 9.81 meters per second squared times the time squared. So we'll take this to the other side. Negative 13.5 meters per second times time is 1/2 of gravity is negative 4.905 meters per second squared, t squared. What will make the math teachers cringe but the physics teachers happy is we'll cancel a t on each side, recognizing we know that t equals 0 is one solution, and we'll cancel the other one out. Then you could take the negative 4.905 over and divide, so you'd have negative 13.5 meters per second, divide by negative 4.905 meters per second squared will give you the time. The meters will cancel, one of the seconds will cancel, and that second that's way down in the denominator will pop up to the top. Your input, I'm going to drop the negatives because it doesn't matter. Negative top bottom cancels. 4.905 and you have a time of 2.75 seconds. So that is the time it takes to hit the ground. Knowing that time of 2.75 seconds, we can then use this time to figure out how far it goes in the x direction. The formula we would use for that is x equals vx times t. You take the vx part, which is written right here, of 23.38 meters per second. You multiply by the time we just calculated, 2.75 seconds, and you will get an x distance that it travels. Bring the calculator back up. We'll just take that time that was there, multiply it by 23.38. That will give 64.35 meters. Not going to need that many significant digits, so I'll round that one off. So that'll be our range, and I'll check if 3 significant digits is good later. The last question you want to know is, what is the maximum height? So one of the ways that we can do this question is to cut the time in half. If it's 2.75 seconds to reach the bottom right here, then it's going to be half of 2.75 seconds to reach its apex. So 1.385 seconds to reach the tippy top of that curve. So we're now going to take and calculate part C. What is the height at that particular time? So we'll still use VIYT 1/2 GT squared. We're solving for y, so we're not going to rearrange anything in the equation. We'll take the VIY, which is a positive 13.5 meters per second, times half that time, which I already forgot the number, 1.385 seconds, plus 1/2 negative 9.81 meters per second squared, times the time squared. Seconds, I forgot to write my units. So I'll input this all in one long go in the calculator. So we have the 13.5 times 1.385 plus half of gravity is going to be negative 4.905 times 1.385 squared. Gives me a height of 9.29 meters. In its height. So that would be how high the projectile goes. Now if we look at number 6, 6 says the kicker kicks the ball with the same speed, so still 27 meters per second, but at an angle of 60 degrees instead of 30 degrees from the vertical. Oh, my crap. Does it say from the vertical? Did the other one say from the vertical? Oops. Above the horizontal and 60 degrees to the vertical. That's not what we want to do. Or 30 degrees from the vertical. Sorry, I can't read. I got sidetracked there. Okay. Why are they trying to distract? Okay, 60 degrees from the horizontal or 30 from the vertical. So we've got it drawn correctly. Question wants the exact same 3 questions. This now goes up, comes back down. We want to know time to hit the ground. We want to know height it reaches, and we want to know how far does it go. Exact same formulas, but what's going to be different when we input here is the 60 degrees. So my Vx is 27 cos 60. My Vy is 27 sine 60. Keep trying to write 30 here. And we'll work each one of them out. So 27 cos 60. Special triangles tells you it's obviously 13.5. 27 sine 60 is going to give you 23.38. Those numbers should be familiar because the Vx and the Vy from the last question have just switched places. Cos of 60 is sine of 30. Sine of 30 is cos of 60. So they flip because they're complementary angles, or supplementary angles. So we can just, you could have just reversed those two numbers that you had from the question before. Same step here, same formula. We recognize that, I wrote 0 here, but the question we want to know what's the time there. Your height here is going to be 0. So we'll again go with the same formula. If y equals VIYT half GT squared, plugging in 0, this time your VIY is 23.38 meters per second times the time minus 4.905 t squared, because it's still 1/2 of gravity. Take this term to the other side, negative 23.38 meters per second times the time is negative 4.905 t squared. Cancel a t, cancel a negative, divide 23.38 over 4.905 meters per second squared will give me the time for this question, for how long it's in the air. So 23.38 divide by 4.905 now gives a time of 4.77 seconds. So we know the time that it's in the air for. Therefore, we can work out how far it goes. X is Vxt. The Vx was 13.5 meters per second. The time, 4.77 seconds. So we take our answer that's there, multiply it by 13.5, 64.4 meters is the X. Last question to work out then is the height at the top. The way we did the last question is we cut the time in half. So cutting the time in half, you have 4.7, so for part C, we will take the time, 4.77 seconds, divide that by 2, will give us a time of 2.385 seconds. We're going to take that time and figure out how high it is using the height formula VIYT, 1/2 GT squared. Y is, the VIY was positive 23.38 meters per second, time of 2.385, and plus 1/2 negative 9.81 meters per second squared, times the time, which was 2.385 squared. Plugging all that in, calculator, take a long step, 23.38 times 2.385, subtract 4.905 times 2.385 squared, gives me 27.86 meters. Much, much higher, 27.9 meters. meters in height. Okay, so we now have, you've kicked it at two different ranges, or sorry, two different angles, and the third question wants you to take these two results from practice problems 5 and 6 and compare them qualitatively. That means I want you to just give a description. When it's 30 degrees, is one bigger than the other? Is one smaller than the other? You don't have to compare the actual numbers, like subtract them or divide them or tell me what percent bigger it is. Just qualitatively compare the flight times. Okay, so the hang time to compare the range, and compare the max height for each one. Okay, so we want to do that for the 30 degrees and for the 60 degrees. So I'll pause this recording for a second and I'll go gather that data just to speed this up. So here's the numbers summarized for the 30 degree and the 60 degree launch. So the amount of time it's in the air at 60 degrees is much longer than it is at 30 degrees. So to qualitatively sum that up, you could say for bigger angles, so when theta is bigger, for bigger angles, the hang time is also bigger. The hang time is bigger. There's a statement that you would say from the qualitative information. The range, when you're looking at the two ranges are the same. They're exactly, well, not exactly equal, but because of some round off in terms of some numbers. But basically, the range for complementary angles, the range will be the same. Okay, so when angles are complementary, the range are equal. And for the maximum height, if you just look at the two values, for the maximum height, it's at a higher angle, it reaches a much higher height. So the third statement you could make, the bigger theta is, the higher the maximum height. Achieved. That might make sense because if you thought about kicking this football at a almost 0 degree angle, it's going to skiff along the ground. If you kick this at an almost 90 degree angle, it's going to go straight up in the air, or almost straight up in the air, and have the highest maximum height. So the bigger the angle is, the higher it goes. Okay, so that's really, the statements were all I was looking for, is to look at the numbers and then write a qualitative statement, meaning we didn't say how many times bigger it got. We didn't look and say, oh, that's about 3 times bigger, because it is about 3 times bigger. We just wanted qualitatively, it's just as theta gets bigger, the height gets bigger. As theta gets bigger, it's in the air longer. So the time is also larger. That's the idea for this question. Now the last one, the rude tourist, insert dork boson. The rude tourist throws a peach pit horizontally with a, I need to move my little recording piece, I'm having trouble seeing it, with a 7 meter per second velocity out of an elevator cage. Where'd you throw a peach pit? It's like those people that spit their sunflower seeds directly on the ground when they're looking, when they're at a movie theater or they're at a baseball game. Like, what are you, an animal? Like, spit it into a bag, throw the bag out. For the love of God, people. Anyhow, So, if you're in the elevator cage, okay, so there's the elevator cage, you're in here, you are 17 meters high at that point, and you throw it horizontally from the elevator, you give it a Vx equaling 7 meters per second. Since it says horizontally, you know that the initial y speed is 0 because it is thrown just exactly, perfectly horizontally to reach the ground. So it is going to go in half of a parabola and strike the ground somewhere. Question wants to know how long will it take to hit the ground. So the distance that the pit falls is actually negative 17 meters because it goes below where it started. It started at this height of 0 and it went downwards. So the height is negative 17. And so if we look at this formula, y equals VIYT, 1/2 GT squared. We plug in the height of negative 17 meters. We know VIY is 0, so 0 times t is 0. That term is gone, and you have 1/2 negative 9.81 meters per second squared, and time squared. So to solve for t, you'll take this term to the other side and divide. So negative 17 meters over negative 4.905 meters per second squared will give you the square of the time, and then we'll take the square root as soon as we're done that. So turn it on the calculator. 17 divide by 4.905 is going to give us 3.47 is what t squared is. So 3.466. But we want to know what t is, so you'll take the square root of that. And so square root of the answer gives 1.86 seconds. So technically it gives plus or minus 1.86 seconds, but that just means if you went backwards following this mathematical parabola, if you went backwards in time, it could have been launched from the ground at negative 1.86 seconds. So we throw that answer out. Obviously the positive one is the answer you're looking for. B, how far away does it go? Horizontally. So we use x equals vxt. We take the 7 meters per second, multiply by the time of 1.86 seconds, and you will get how far it goes. Take your answer times 7, and you get 13.0 meters. Now, part C says he throws the next pit when the elevator's at the same height, but now it's moving upwards at a constant speed of 8.5 meters per second. Now how long does it take to hit the ground, and how far away does it go? So what changes in this part of the question is the elevator's here. It's at the pit is still going to fall negative 17 meters. You're still throwing it horizontally, Vx at 7 meters per second. But the person holding the pit, the rude tourist, is also moving up at 8.5 meters per second. So that means at the instant that they launch this horizontally, the pit is also moving up at 8.5 meters per second as well. So now you have a VIY of 8.5, and you're going to use the same formulas. This time, from somebody standing on the side, they are going to see the peach pit go up in the air, and come back down. So because it has an upward velocity, it is going to move up first and then come back down. Therefore, it will take longer to hit the ground. Going back to our formula, y equals VIYT plus 1/2 GT squared. Your height is negative 17 meters per second. Your VIY is positive 8.5 T. 1/2 gravity is still negative 4.905 T squared. Well, now the T's don't cancel. This becomes much more challenging to solve. I will take this, make it equal 0. I will put the T squared term first. I will put plus 8.5 T and plus 17, because the negative 17 on the left becomes a positive on the right. Now you have a quadratic equation. You have to input an A value of negative 4.905, a B value of 8.5, and a C value of 17 into the quadratic formula, negative B plus or minus square root B squared minus 4AC all over 2A. Gross. So, slowly plugging those numbers in, negative 8.5 plus or minus 8.5 squared minus 4 times negative 4.905 and 17 all over 2A, so negative 9.81. So negative 8.5 plus or minus. I'll work out just what's under the square root first on the calculator, so I could trace back and find errors if they're ever made. So we will take 8.5 squared. You're going to add 4 times 4.905 times 17. Under the square root, you should have 405.79. So my next statement I would then write is negative 8.5 plus or minus whatever that square root is going to be, and then over 9.81. So take the square root of that answer, and you get 20.14. And so at this point, you've got two different answers. You have negative 8.5 plus 20.14 over negative 9.81, and negative 8.5 minus 20.14 over negative 9.81. This answer, when you add the two of them together, you'll get a positive number. You'll divide it by a negative, and you will get a negative answer, which does not make sense. So we don't care about that answer. We are only going to worry about the positive one. So you're looking to take negative 28.64 and divide that by negative 9.81. So we're going to take 28.64 and 9.81. Divide those two, you get a time of 2.92 seconds. That is in the air, indeed long. 2.92 seconds. And then, since it's in the air longer, I think C asked you, D said how far away will it land? So you still can then work out, take this time, and use the same formula, x equals dxt, as used in the other part. So you still throw it horizontally, 7 meters per second. So if you want to know how far it goes horizontally, you use the speed horizontally, and the 2.92 seconds, and multiply those two numbers together, and get yourself an answer. So times 7, 20.4 meters. Okay, long video to get there, but there's all of our solutions for those questions. Hopefully that clears up any of the problems you had. I'll do some theory questions that were also on the sheet in the next video.